Hi friends, this is Professor Shrikant Karnewar. I will teach you today the problems on linkage and crossing over. This is a part of our GPB 121 Fundamentals of Genetics, exercise number 14. So today we'll learn about 4 problems. And first of all, try to understand what is meant by linkage. Linkage means it is a tendency of two or more genes to stay together during inheritance. इट इज कॉल्ड ॲज लिंकेज. लिंकेज म्हणजे काय की आपण आपल्या आईवडिलांसारखं दिसतो, मग तो कशामुळे दिसतोय तर तो लिंकेजमुळे दिसतो, याला म्हणायचं लिंकेज. So today we'll learn about 4 problems, and these 4 problems can be categorized into 2 parts. First 2 problems that are based on F2 population data. F2 means what? When F1 is crossed with F1, we will obtain F2 population. F1 means what? F1 means first progeny after crossing over between 2 parents. And this is the first problem that is based on F2 population. Here we will use the formula of p square it is equal to E minus m upon n. And second category problem, so which is based on test cross data. Test cross means what? Test cross means when a cross is made between F1 with its double recessive parent, so that it is called as test cross. Whenever in our problem, whenever there is a word of test cross, so in that case we will use the formula of crossing over in percentage. It's equal to recombinants upon total combinations whole multiplied by 100. So let us see one by one. In this exercise, there are 2 different formulas. First formula, so that it is p square, it is equal to E minus m upon n. So when this formula, it needs to be used whenever in our problem. So where there is a word, which is this word, that is, it is a F2 population. Whenever this word appears in our problem, in that case we have to use this formula, so that it is p square it is equal to E minus m upon n. So another formula that also it needs to be used while solving the problems of this exercise, another formula, so that it is crossing over it is equal to recombinants upon total combinations multiplied by 100. So when this formula it needs to be used whenever in our problem, so whenever there is a word of back cross with double recessive parent, this double recessive parent, this word is very very important. Whenever this word will appear in our problem, in that case we will use this formula, that is crossing over in percentage is equal to recombinants upon total combinations multiplied by 100. Now let us see the first problem of this exercise, so that it is in certain F2 population shows following frequency. So calculate linkage and crossover value. So values are given. Which are those values? That it is capital A, capital B, that is it is 357, capital A small b it's 37, small a capital B 33, and small a small b 94. This much of the values are given in our problem. So as already we learned that here it is a use of F2 population, that's why we have to use this formula, so that it is p square it is equal to E minus m upon n. So now try to understand what is meant by E, what is meant by m, and what is meant by n. Firstly, p it is a linkage value, E it is a sum of all the end classes, m is sum of the middle classes, and n is the sum of total population. So here once we put all these values into this formula, that it is p square it is equal to, these are the end values. Which are those end values? That it is 357 and 94. That sum of these two end values, that it represents the value of what? It represents the value of E. That's why we have written here 357 plus 94. That these are the values of E. That means these are the sum of all the values of int classes, minus M. M means what? Sum of middle values. Which are those middle values here in this case? That it is 37 and 33. So that's why, so E minus M divided by N. N means what? It is the sum of all these four values. That means 357, 37, 33 and 94. So when we have put it all these values into the given formula, so that the answer is 381 divided by 521. So these are the values for p square. Now, so we had to find out the answer for values of p. That's why we made it under root 0.73. That's why p is equal to 0.854. How this answer is came 0.854? Because it's a under root of 0.73. So now when we express this 0.854 values in terms of percentage, therefore p value is equal to 85.40. So that's why our linkage value is 85.40%. So now how we can calculate the crossover value? In simple terms, crossover value is equal to 100 minus linkage value. That's why 100 minus 85.40, it is equal to 14.7%. So that's why, what is the result of this problem? So the linkage value of population is 85.40 and crossover value of this given problem is 14.7%. Now just overlook this problem. So first of all these values are given. Try to find out the values of E and M. Then put all these values into the given formula. So these are the values of sum of int classes. These are the values of sum of middle classes divided by sum of all the values, that is 357 plus 37 plus 33 plus 94. And so try to find out the answer for p square. Then find out the answer for p and express it in terms of percentage. And whenever we have this linkage value, make it minus it from 100. The final our overall answer will be 14.7 of crossover value. Finally, write down the results. That is, linkage value of population is 85.40 and crossover value is 14.7%. Now we will see another problem, which is that problem when Batson and Punnett made a cross between purple flowered long anthered sweet pea plant and red flower round anthered plant. The F1 was purple flowered and long anthered. In F2, 4831 were purple flowered and long anthered, and 387 purple round and 393 red long and 1339 red round progenies is obtained. Calculate the linkage value and crossover value. So here in this case, which word is more appeared? So that this F2 population. So as here is a word of this F2 population, we have to use this formula, so that it is p square is equal to E minus M upon N. Simply, so this is the first value, that it is 44831. Second value, so which is the second value, that it is 387, and the third value that is 393, and the fourth value, so that it is a 1339. So out of these four values, so these two values we can call it as an end values, and these two values are called as m values. N values means this, so these are the parental values, which are those parents so that it is a first parent, so that it is a purple long anthered, and second parent that is a red round plant. So here we have these four values. First of all, we identified which are those e values and which are those m values. So we'll put all these values into the given formula, so that it is equal to p square, it is equal to 4831. This is the 4831 value. And end values, that is this value, this is 1339. These are the sum of end classes minus sum of middle classes, that is 387 plus 393, divided by sum of all the values, that means 4891, 1339, 387 and 393. So when we made it calculation, so final answer will obtain after putting all these values into the given formula, so that it is p square is equal to 0.77. So to find out the answer for p, so we had to remove this h square, so make it square root, so that is 0.77. The final value of p is equal to 0.877. So that's why the final value of p is 87.7%. Now, so when we have obtained this linkage value, that is 87.7%, now the crossover value is 100 minus linkage value, that is 100 minus 87.7, it is equal to 12.3. So the final answer of this crossover value is 12.3%. Now the final answer is linkage value of population is 87.7%. Do not forget to write this it's in terms of percentage, and the final crossover value is 12.3%. So in this way we can calculate linkage value and crossover value of this given problem. So in this way you can calculate the linkage and crossover value of this problem also. Hi friends, we'll see another problem that is based on the value of the test cross data. So first of all, overlook this problem. This problem is a homozygous purple long fruited plant was crossed with homozygous red round. The purple long F1 was backcrossed with double recessive parent, with which gives following results. First is purple long 702, red long 77, purple round 83 and red round 698. Find out the linkage value. So here in this case, so first of all, which is our parents, that is purple long. Say for example, so this is our purple long. It is crossed with what? Purple long plant was crossed with homozygous red round. So here we will write purple long crossed with red round. So these are our parents. So which is our F1? F1 is that when our these parents, which are those parents, purple long fruited plant was crossed with red round. The purple long F1 was, which is our F1, that is purple long, it is our F1. When it is crossed with which parent? So it is crossed with double recessive parent. Means what? So it is crossed with its red round parent. So as this data is of test cross, that's why we have to use this formula, that is crossing over is equal to recombinants upon total combinations multiplied by 100. So here the most crucial thing is that to find out the recombinants. Recombinant means that those which are not parental one. Which are those parental one in this case? that is purple long and red round. So these are the parental characteristics and these are the recombinant characteristics. Parental characteristics means what? The initially which words are used, that is homozygous long fruited plant, that it is purple long fruited plant. So this is our parent, which is another parent. So this is our another parent, that is red round. So that's why purple long and red round, these are the parental characteristics and these are the recombinants. So firstly identify the parental combinations and recombinants, then put all these values into the given formula, which is the simplest formula for this, that crossing over in percentage is equal to recombinants upon total combinations multiplied by 100 here. So which are those recombinants here? So these two, sum of these two, that means 77 plus 83 divided by total combinations. Total combination means what? The sum of all the values, that is 702, 77, 83 and 698. So these are the total combinations, whole multiplied by 100. So what is the answer for 77 plus 83? That it is 160 divided by 1560, whole multiplied by 100. So what is the final answer for this problem? That is crossover value is equal to 10.25%. So now how we will obtain the values, that is linkage value? Simply 100 minus linkage value, that means 89. 100 minus 10.25 is equal to 89.75 percentage. So what is our final result? Linkage value of above population is 89.75% and crossing over value is 10.25%. Hi friends, now today we'll discuss about the fourth problem, which is based on linkage and crossing over. Now this is our next problem, which is related with linkage and crossing over. So in this problem, so what is given in this problem? An individual for genes CD is crossed with wild type. F1 is backcrossed with double recessive parent. The appearance of offspring is as follows, that is plus it's 903, CD 897, plus D 98 and C plus 102. What is given in this problem? That CD it is crossed with a wild phenotype. So these are our parents. This is female parent and this is a male parent. As what is the F1? F1 is CD upon plus. So this is our F1. So when this F1, it is crossed with its double recessive parent. So what are the following frequencies which were obtained? That plus were 902, then CD it is 897, then plus D it is 98 and C plus it is 102. So as this CD and plus these are the parental combinations. So that's why we will see that these are two are the parental one and these two we can say these are the parental one and these two these are the recombinant one. So first crucial thing in this problem is that to identify the parental combinations and recombinant combinations. So once we have obtained these words into this problem, that is crossed with double recessive parent, that means it is a data of test cross. That's why it is essential to use this formula, that is crossing over in percentage is equal to recombinants upon total combinations multiplied by 100. So here in this case, which are those recombinant one? So these two are recombinant one, these two are the parental one and these two are recombinant one. So first of all, put all the values into the given formula, that is recombinant one means what? 98 plus 102. These are the recombinants. 98 plus 102 divided by total combinations. Total combinations means what? It is a sum of all the combination, that is 903, 897, 98 and 102. And finally we will obtain these values, that is 200 divided by 2000 whole multiplied by 100. So now crossing over in percentage is equal to 10%. That means 200 divided by 2000 multiplied by 100. Hence the linkage value in percentage, it is equal to 100 minus crossing over value. That's why 100 minus 10. So hence we will get the value of 90%. Finally, we can interpret the result that strength of linkage in above population is how much? 90%, and the crossing over between the genes of above population is 10%. So in this way we can solve this formula. Finally, you may write down this formula into our given problem.